Hi, I'm Tim the Smark, and I'm here for another session of Farm Boy Splainin', the show where I take a seemingly complicated or nonsensical thing and break it down using science and physics and logical reasoning and explain it the best way I possibly can in the simplest terms um, possible. Right. So, right. Here I am once again, ready to answer another question. The answer that I want to address is something that you might have pondered someday, some evening, looking up at the stars. You might have asked yourself, are there aliens out there circling some distant star, one of those tiny little shiny dots, looking at us? Well, the answer to that question is there might be. But if there are, they most certainly wouldn't see us. They would be seeing, I don't know, our ancestors or maybe even dinosaurs. So why would aliens see dinosaurs? That doesn't make any sense. So let me Farm Boy explain it to you. So, let's just start with the hypothetical situation. So let's imagine there's an alien race around, orbiting some other planet who their society has their priorities in line well enough that they actually fund space research and they actually, as a society contributed enough money into their NASA analog to have a big, giant, supermassive telescope. You imagine something as grandiose as, I don't know, a sports stadium. Something big and impressive that was huge and had the capability of looking through the vast expanse of space to go, to see all the way to Earth and to see Earth's surface with enough granular detail that they would be able to see the life forms living on it. They could observe the everyday lives of those creatures. The thing is that they definitely wouldn't see us, me or anybody watching this video. Like I said before, they would see maybe Neanderthals or maybe even dinosaurs. Maybe they would see an Earth that has no life on it yet. And the reason for that is because of how lenses work. So let's say that you want to see something. Like perhaps I want to make a video with both audio and visual components. In order for the audio to work, all I need is my voice and a microphone. But in order for the visual aspects of a video to work, I have to have a light source, like my sun analog, which is just my light, which is right there. And light from that sun analog has to travel from there, hit me, and then bounce off of me and go into the, it's over there, the lens of my camera. So this happens seemingly instantaneously. The light comes from the light, photons come from the light, bounce off of me, and go to the camera. Happens so quick we can't tell that happens. But if I move to the back of the room, it'll take slightly longer for those photons to go from me into the lens. And if I move even further back, you're not going to be able to see it at all because I'll be on the other side of the wall. But if we move that distance, let's say I go to the moon. and I'm on the moon, and we gotta wait for light to come from the sun to get to the moon where I am and bounce off of me and then go to my lens and my camera. If I, say I point my camera at the moon. That's going to start taking longer. It takes about 7 minutes for light to get from the sun to the Earth, or the moon. I don't know how long. It takes less than that to get from the moon to the Earth. But it takes a perceptible amount of time. We will perceive that thing. Now, if instead of the moon I was on, say, some planet that was a light year away, say I set up my observatory a light year away from Earth, and so light from the sun hits the Earth and then bounces off and goes all the way to my observatory 1 light year away. Now, to clarify, a light year is a measure of distance, just like a foot or a meter or a cubit. It's a distance of length. So a light year is the distance that light travels in 1 year. And so from my observatory, 1 light year away from Earth, I would observe not today, but I would observe a year in the past, because light from the sun hits the Earth, bounces off whatever is happening at that moment, and then starts heading towards my observatory, my telescope. And by the time it enters the lens of my telescope, it's taken that light a year to get to my telescope from Earth, and so what I observe in my telescope is an image of Earth a year in the past. Now, if we increase that distance to more than 1 light year, we'll see further and further into the past. And so when we start looking, the distances in space are so astronomically large that it's, there are stars far enough away from us that observatories circling them would look at Earth so far into the past that it would be unrecognizable. I mean, our society would be unrecognizable, is what I meant to say. We wouldn't have cars, we wouldn't have nothing. Maybe even if they were far enough away, they would see dinosaurs. And so that right there is hopefully a nice explanation as to why aliens looking at Earth would not see us looking at them. Rather, they would see something in the past, depending on how far they are away from Earth. And yeah, so I have been Tim, and that's Farm Boy Splaining.